So today we're going to continue using our trig functions to solve triangles. So when it asks you to solve a triangle, it's asking you to find all of the missing pieces. So for our triangle in number 1, I want you to stop the video, give it a shot, find all of the missing pieces. We need to find angle J. We know angle J. We need to find angle L. We need to find side LK, and we need to find side JK. And you should have all of the tools that you need to solve those using trig functions, please, with this. So let's use the trig function. So pause the video, give those a shot, and let's see how you do on that. So the first thing we'll do is, well, we can find angle L by just subtracting 26 degrees from 90, which gives us an angle of 64 degrees. So this is 64 degrees. So 64 degrees. Then we can find side LK. Remember, what I need to do is I need to look at LK, and I need to determine what I have and what I need to have. So I have this angle 26, so I can say, and I know the hypotenuse here, and so I know that this is the opposite side. So if I have opposite and hypotenuse, remembering SOHCAHTOA, I can use my sine. So I can set it up that the sine of 26 degrees equals LK over 3.2, opposite over hypotenuse. So 3.2 times the sine of 26 degrees equals LK. That's calculator ready form. I like that. And then I'm going to put it into my calculator. 33.2 sine 26. That's if you're using that TI. You can do that, and I get LK equals 1.4. Remember, if you're using one of the iPad calculators, that you need to put it in as 26 sine 3.2, and that will get you this same answer. So this is the answer you're looking for. I want everyone to use their calculators and try to figure out if they're using their using it correctly. I want to make sure we're using our calculators correctly for these. All right, so then the next side that I have to find is JK. And looking at that, I can see that I have 26 degrees and that JK is my adjacent side. So I could use the cosine, because cosine is adjacent over hypotenuse, right? So I can use my cosine, so I could say the cosine of 26 degrees equals my JK over the hypotenuse. So 3.2 cosine 26 is JK. So again, into the calculator, and I get 2.87. So one of the things I'd like you to, or rounding to 2.9. One of the things I'd like you to double check then next is to make sure that your answer makes sense. So looking at this, if I put this back in, that LK is 1.4 and JK is 2.9, I look at this and I see, okay, JK should be my bigger side because it's across from my larger angle. LK should be my smaller side. It's across from my smaller angle. And JL should be my biggest side because it is the hypotenuse. So these answers make sense. So I would always encourage you to go back and make sure your answers make sense. Okay, the next one we have is number 2. And number 2 is a little bit of a problem. We can find our third side. Stop for a minute. Like I said, stop the video. See if you can think about how to find the third side. We don't know any angles, so it doesn't appear that we can use SOHCAHTOA at the moment because I don't have an angle. So you have to remember we have to have an angle to be able to use that. And I don't have an angle. So I'm going to need to find angles. So I could find the third side. I could find QR using a Pythagorean theorem, right? So that would be 8.3 is the hypotenuse, so that's my c squared. To make that go away. So that is my c squared. So 8.3 squared equals 6.7 squared plus b squared. Or I could say plus QR squared. All right, so plus QR squared. Again, so into the calculator, so that is 68.89, and then that is so I get 24 equals QR squared. So I can take the square root of 24. Again, this might be some good practice for your calculators. And I get 4.89 or 4.9 for that side. Okay, so now we have that all of the sides. That's great, but we still need angle P and angle R. So if you remember from our first lesson on the sine, cosine, tangent ratios, I showed you a little trick for finding the angles. So we find the angles using that either inverse sine, inverse cosine, or inverse tangent. So if you recall those are the inverses. You find those using the second key on your calculator, or some of you it might be a shift key. So I saw a calculator the other day that used the shift key to get to these inverse numbers. Okay, so let's just set it up. I'm going to find angle P first. So I see with P, and again, I'm going to use my given values because I know that I rounded that one. So I don't want to use that value if at all possible. Okay, so then what I have is I have the hypotenuse, and for P I have the adjacent side. So I'm going to use sine. Cosine. So the cosine of P equals 6.7 over 8.3. Now remember, I can't, if I do 6.7 divided by 8.3, which is 0.8072, and I take the cosine of that, that's not going to be my answer. So, because I can't find angles using cosine. So what we do is basically we use this inverse function, and what it does, I'll do cosine inverse to this side. I'll do cosine inverse to this side. And what it does is it cancels that cosine out and leaves me just P. And that's what I'm trying to get. So P equals inverse cosine of 6.7 over 8.3. This is my calculator ready form. That's what I put in the calculator. So on my calculator, which is a TI-83 or TI-84, or whatever you have, I'm going to go in and I'm going to do second cosine. That gets me that little inverse number. And then I'm going to just, in the parentheses, I've got 6.7 divided by 8.3. And I'm going to get 36 degrees. So P equals 36.2 degrees if I round it. At this point, at 36.2, I can subtract that from 90 and get my second side, which is going to be 53.8 degrees. So R is 53.8 degrees. And I can just get that from subtracting from 90 to get that. So that's how we solve triangles. And I wanted to just make sure we took a time to refresh our memory on this inverse thing. So let's see what we have next. All right, here's one. It says find the following side lengths and angle measure to the nearest degree. All right, they gave me some coordinates. I'm going to have to draw a picture. So let's see what we've got here. I'm going to draw my graph. It's a horrible graph. Not much better. All right, so I have my graph there. Let's see. All right, so I have this triangle here. First thing I'm going to need to know is I need the side lengths and the angle measures, okay? So let's find the side lengths. So I know that the side length for MN, this side right here, and it's a vertical line, so it's the length from -2 to +2, so it's 4. Then I can find this side length here. It's the length from -1 to 3, which is also 4. So I automatically now, I know that that's a 90-degree angle because I know that I have vertical and horizontal lines. I know that these sides are congruent, so I should know then that my angles are 45-degree angles. So I've got a 45, 45, 90-degree angle. I can find my third side. My third side I can find, well, maybe Pythagorean theorem, but there's such an easier way. If you know your 45, 45, 90 relations, then the hypotenuse is simply 4 radical 2. That was easy enough. All right, let's look down here at this, at number 4. It says complete these statements. So the tangent of what angle is 3.5? Well, so basically what I'm looking for is I'm looking for some angle, tangent of some angle A. I'm looking for A. So remember, how do we get rid of that? If I have tangent of A equals 3.5, I can take that inverse tangent. Remember the inverse tangent, I'm looking for an angle. The inverse tangent cancels that out and leaves me with just the angle. And then I have to do that to both sides. So the inverse tangent of 3.5, so second tangent 3.5, and I get 74.05 degrees for angle A. If you have the iPad calculators, you're going to type in the 3.5 first and then the inverse tan, and you should get 74.05. So I want you to try that. Then for the B problem, well, we're looking for the blank of 42 equals 0.74. Well, it's got to either be sine, cosine, or tangent. This one's just trial and error. Put it into your calculator. See which one works. Cosine 42. Oh, that's the one that works. So in this case, it was cosine. Sine of what angle equals 69 degrees? So, I mean, or the sine, actually that is the angle, right? So we know that the angle is 69 degrees. And so I need to know, so what am I looking for to get 69 degrees? So I'm working it backwards, right? So I'm going to be doing, actually taking the inverse sine. Sorry about that. This one should read the second sine. That's right. That should read inverse sine of what equals 69 degrees, because we're looking for the angle, right? And so if we're trying to get the angle, we're taking the inverse sine. So basically what you would do to find that is you'd find out what is the sine of 69 degrees. That is 0.933. So 0.9335. And look, if you put that in your calculator under second sine, 0.9335, you get 69 degrees. So for that one, again, you take the sine of that, of both sides, and you would get the answer. So remember that sine cancels out inverse sine, and inverse sine cancels out sine. So you can do it both ways. So in this case, if I take the sine of both sides, it cancels that out, and it leaves me with what my answer is. All right? So those are just some interesting ways to take a look at sine and cosine. Here's one more problem relating to that. So we want to find the indicated measure in the rectangle. It's asking me for angle BDC, which is this angle right here. So I'm looking for BDC. First thing I know, I have a rectangle. Again, if you want to work on this on your own, go ahead and do that. Turn the video off. So I know it's a rectangle, so I know that's 7 and that's 2. So now I also know that I have right angles if it's a rectangle. So here I see then that I have this right triangle. So that right triangle, and I've got two sides, and I'm looking for that angle. So I'm going to be using inverses because remember, I'm looking for an angle. So again, pause the video if you want to try this on your own. So I'm going to set it up. I've got the opposite and the adjacent. So I'm going to use tangent. So I'm going to set it up that the tangent of angle BDC equals 2/7. So remember, I want to get rid of tangent because I want to get my angle by itself. So to get rid of a tangent, I use an inverse tangent. I have to do it to both sides. That cancels, and I get angle BDC equals inverse tangent of 2/7. Here's calculator ready form. So I go to my calculator, and on my TI, I press second tangent, and then in the parentheses, 2 divided by 7, close my parentheses, and I end up with angle BDC equals 15.9 degrees, or approximately 16 degrees. You guys on your iPad computers, again, you'll put the 2/7 in first, and then the inverse tan function. All right, so that's how we do that. So you'll have some exercises on finding angles. I also want to talk about a few more things, especially since we're dealing with angles. And I want to talk about the angle of inclination and the angle of depression. So an angle of inclination is the angle formed by, and these are important words, angles formed by a horizontal line and the line of sight to a point above the line. And the angle of depression is formed by a horizontal line and of line of sight to a point below the line. Okay, so let's take a look at this picture. So angle 3 here, this little angle right there, it is from, if you look, it's from the eagle or the bird is looking down at the man. So here's the horizontal, here's his line of sight, that is the angle. So angle 3 is an angle of depression. Angle 4, that's this angle right here, And that is the angle, that's the man looking up at the bird. So here's his horizontal. There's his line of sight. So horizontal up to line of sight is an angle of inclination. And then we have this angle here, the angle 5. That's the man looking down the top of that tree. So this, number 5, is an angle of depression. And then we have this angle 6, which would be something in the top of that tree looking up at the man. So that would be an angle of inclination. Basically, incline is up, depression is down. But let's be careful. And let's take a look at some things. All right, first of all, we have this one. We have when the angle of depression of the sun is 37 degrees, a flagpole casts a shadow 24.2 feet long. What's the height of the flagpole? All right, so here's my flag. Let's try that again. So here's my flagpole. So there's my flagpole. All right, so I've got the angle of depression of the sun. So the sun's coming up, here's the sun, and it's shining down on the flagpole. And it creates, here's the ground, okay? All right, so let's talk about some angles. So it says that the angle of depression. So let's draw my angle of depression is always measured from the horizontal to the line of sight. So from the sun, horizontal to the line of sight is right here. So this angle is 37 degrees. Now, that's a horizontal line. My ground is a horizontal line, right? So this angle down here is also 37 degrees because these are alternate interior angles. So now look, I have this little triangle right here. And if I want to know how tall the flagpole is, I can solve for that. I know that the shadow is 24.2 feet. That's down here on the ground, the shadow that it casts. So I'm going to set up using one of my trig functions. I have the opposite and the adjacent, so I'm going to use, again, if you want to figure this out on your own, shut the video down. So I'm going to use the tangent of 37 degrees equals x over 24.2. So 24.2 feet equals, times, let's try that again, 24.2 times the tangent of 37 equals x. That's calculator ready form. I'll put that into the calculator. So I got 18 feet-ish, 18.2. I guess we'll keep it at 18.2 since it was originally 18.2 feet tall is the measure of that. All right, let's look at another one. We've got a forest ranger is in a 120-foot observation tower. So let's see, we've got the tower here. So he's in a fire tower here. And he sees this blazing flat fire over here. And so here he is right here on his fire tower. It's 120 feet up. And he is looking at the fire. All right, so he's looking at the fire. Now, here's the tricky part. The angle of depression to the fire is 3.5 degrees. keeping in mind what you know about an angle of depression, where is that angle? Take a minute, complete the picture, and label that angle 3.5 degrees. So turn off the video and then come back. So remember, angles of depression are always formed by the distance from the horizontal. So the angle of depression to the fire is actually this angle right here, 3.5 degrees. It also is the same as this one here. This one would also be 3.5 degrees by parallel lines, transversals, and alternate interior angles. So now what I'm looking for is the distance to the fire. So I'm going to say I've got opposite and adjacent. So again, I'm going to use tangent. The tangent of 3.5 equals 120 over x. So x tan 3.5 equals 120. So x equals okay, hold on, I'm having some issues here. There we go. So let's see. Let's try it here. Oh, let's try it here. Okay, so x equals 120 divided by tangent 35 degrees. So again, I'll put it into my calculator. And I get 171 feet from the fire. So the fire tower is 171 feet from the fire tower. So that's how you do those. So be careful because a lot of people want to say that this angle here is the angle of depression, and it is not. It is never. That is not from the horizontal. Remember, it always has to be measured from the horizontal, okay? And that's what we've got. So that's our discussion on the finding the angles using those trig functions and the inverse trig functions, and then angles of depression and angle of inclination. So the assignment is posted, and you can begin work on that. And I'm sure you'll have some questions, and we will go over those together in class. Thanks.